Well, hello everyone. Thank you for joining the P4 Brigade call. It's been 2 weeks since the last call. Last week we were pretty much busy with core build and other events. So the first item on the agenda is a quick update on last week. So as I said, we had core build. During core build, we gave a talk about the work we're doing in the brigade and court. Originally, the brigade is a ONOS brigade, but now we started working on the use cases we're working on are very related to cord, or at least Fabric.P4 and the VNF offloading. Then in some sense also INT, it's related to cord because it will be used by a cord. So at this link you can find the slides I presented, which I briefly talk about the plans for P4 and cord. I know Bora from Netsia had a talk about a cord in which he mentioned INT. I don't know if you, sir, can have the link to that talk. Maybe you want to add it to the agenda so that other people can have a look. Then on Friday, there was the P4 Developer Day. This is the official developer day of the P4.org community. It was held at Stanford. And Brian and I were invited to give a short session on P4 on time, a 45-minute session on P4 on time. The whole day then was mostly about P4, the language, on how to write P4 programs. I put here the slides that we created, and if you're not very familiar still with P4 on time, I suggest you to have a look at the slides. I think there's a nice introduction to what P4 on time is and how it works. And at some point, there should be also they should release the recording of the day soon on YouTube, so you should be able to watch the session. During the session, we also show a demo of our ONOS application controlling a network of BMV2 devices, of P4 devices. If you're interested, you can find here the code of the application. I guess that's all. Is there any question about last week events? Okay, let's move on. So Fabric.P4. So last time we talked about, Yi and I created some pointers for Fabric.P4 for members of what we now call the Fabric.P4 working group, to learn what Fabric is and how it works, and most important, the prototype code Yi has been working on. So I asked people to have a look at the pointers, get a grasp of what Fabric is, and review code that Yi has been committing to Garrett. I don't know if that happened. If you have any questions about the work we're doing, please feel free to ask, even if you don't really understand what's going on. This would be a good start. In the last days, Yi and I have sit down and have tried to find a way such that we can make this work more modular, so that we can have more members contribute to this. And we created a few slides. They're available with this link, and I would like to present. Okay, so basically we are trying to re-architect the current implementation of the Fabric.P4 pipeliner. What's the problem? The problem is that we realized that understanding how Trellis works is hard for first-timers, especially if you never used Cord, if you never used Trellis, and if you never try to at least run the Mininet-based environment. So at the same time, we want, given the tight deadline we put on ourselves, which is to have a first working version by next month, we want Brigade members to be able to help contribute code as soon as possible. We realized the biggest chunk of work for Fabric.P4 resides in ONOS, because it's there where we have to write this big driver that we call the pipeliner. I'll explain what it is later. And this is definitely the biggest chunk of work. We already have the P4 code defining the pipeline, and we have some confidence that that will work, even if we didn't do any. We should test it more, but we need help with ONOS and with Java code to write the pipeliner. There we need to implement some translation logic of the flow objectives and unit testing. So the solution that Yi and I decided to implement instead of re-architecting the current pipeliner implementation for better modularity. And it's also the result of a few lessons we learned, especially Yi learned when working on the existing OFDPA pipeliner. So what is the pipeliners? If you're not yet familiar with the ONOS architecture, we have applications on top of ONOS that program the network using flow objectives. So flow objectives is an abstraction that allows applications to be independent from the specific pipeline structure on the device. So the idea is that applications should program the network independently if the device is using a OFDPA pipeline or a pipeline from other vendors, or maybe a P4 custom pipeline. So the way it works is that device vendors, or in this case P4 program writers, provide what we call a pipeliner. Pipeliner is a behavior that is part of the drivers in ONOS, the device or P4 program drivers in ONOS. The pipeliner is the one responsible of translating a flow objective into multiple flow rules and groups that are specific to that pipeline. In this case, with groups, we intend groups in the OpenFlow.
Can I ask you a quick question? Does the application is written...
sense of the word. So is that... Sorry, can you repeat the question?
Yeah. Is the application...
Can you repeat the question, Tom?
Yeah. The question is the application is written in P4 or...
Again, please.
Okay.
So the application is current application. We use segment routing application in Trellis.
Oh, I see. Okay.
Yeah, and Trellis will generate flow objectives to the pipeline. So currently we use OFDPA pipeline to generate rows and groups for the OFDPA switches.
You haven't talked about P4 yet. Right?
Yeah, our goal is to impact applications as little as possible, because the translation logic is under that.
Got it.
And the end result is that actually if you get a 2x2 leaf spine perfect base with the edge core devices, you just could go in any core deployment, plug out the Broadcom base, put in the barefoot one, and from the services perspective and the deployment perspective, nothing changes.
I guess my confusion is like, where is the P4 come to the play here? Where is it under?
Not yet here.
Not yet.
No, not here yet.
Okay.
The
It's the lower level.
Yeah, exactly. The P4 here, the program comes at a lower level, so it comes where from you need to install the program on the device. Then on top of this, you have the segment routing application, the pipeliner that uses flow rule service and group service. This is all in ONOS. ONOS needs the P4 program because it needs to understand some concepts of the P4 program to program the switch. But the P4 program is somewhat at the side that gets installed by ONOS when it recognizes that that is a P4 switch.
Right. So Southbound could be either OpenFlow or it could be P4.
No, it needs to be P4 runtime.
P4 as a
It needs to be P4 runtime.
Okay. I think we also...
Yeah, so maybe...
Maybe we can take it to
Sure.
That's fine.
So this can be maybe a better architecture picture. So you have the device pipeline at the bottom, and on top you have
Carmelo?
ONOS application. So this pipeline can be, you guys hear me?
Yeah.
Yeah, we lost you for a second.
But can you now hear me well?
Yes.
Yeah.
Okay. So the device pipeline in this case can be fixed function or P4 programmable. Okay. Yeah. So Okay, so this is what we have to implement for Fabric.P4. We already have a pipeliner for OFDPA, and if you look at the pointers I gave last week, it's a piece of code with a bit of complexity, actually more than a bit of complexity. So what's the problem with the pipeliner implementation? The problem there is that the trellis application, sorry, the segment charting application issues different kinds of flow objectives. So you can think the flow objective. So you can think the flow objective as abstraction as a three-stage pipeline, in which the first stage is just filtering, the second one applies forwarding rules, and the third stage is groups. In any case, for each of the stage, we define language based on the set of criteria and actions that are defined in each flow objective. The pipeliner decides to which for which specific tables of the pipeline it should generate flow rules. So right now, we realize that this mapping between the specific tables of the pipeline and the flow objective can be derived mostly from the criteria. So from the match fields defined in each flow objective. I mean, at least this was my understanding by talking with Yi. It might be that in the future we need to consider also the actions. In any case, for trellis, what happens is that we can think of an abstraction in which trellis sends down different kind of flow objective, each one representing what we call forwarding function type. Or again, if you have a look at the pointers I gave last week, there's a document by Yi with some design notes that explains what we support, things like layer 2 unicast, so basic layer 2 bridging. We have some support for layer 2 broadcast inside the same VLAN. We have support, and also I think in this picture we're missing things like support for rules that are used to handle R packets, DHCP, in those applications. So anyways, you can see on the right, we have what we call these forwarding function types. On the left, we have the criteria that can be used on a flow objective. So you can see there is a map of specific criteria and Can you guys still hear me?
I think your network comes and goes. We can hear fine. Hello? Some pieces, and then we miss a lot of pieces.
Did you guys miss a lot of what I just said?
Somewhat, yes. Not a lot, but just like a few words here and there.
Did I repeat anything, you think?
Probably not. I think was kind of understandable, but just make sure that your network connection is okay.
Yeah. Control network, my own network connection just. Okay, yeah. The bottom line here is that to support Fabric, to support a P4 Fabric, we need to implement a P4 program that is able to support a different, and also we need to provide a pipeliner implement able to handle FFTs to be mapped to the table entries for the pipeline specific tables. So you can see we already found a way to modularize the pipeliner implementation.
Carmelo, sorry.
Yes.
You come and go. Can you call in for the audio?
Yes, I can.
Thanks, because like it really, like, it drops few words and the sense of what you're saying is not
Okay.
understand.
Okay, I will call. Just give me a second.
While Carmelo is calling, I have a question. Changing the OFDPA pipeline would affect other consumers of the OFDPA, such as core projects?
Hi, this is E. We won't change the OFDPA pipeline. We'll create the pipeliner for Fabric.P4.
So the other consumers wouldn't be affected, right?
No.
Won't affect any OFDPA pipeliner.
All right.
The idea is that this is completely transparent to any end user of Core. At least for now. In the future, we might introduce more services that we will expose. But for now, it's completely transparent to any end user of Core. As I was saying to Tom before, you should be able to plug in this fabric instead of the OFDPA one and deploy Core as is.
Yes, but the intent is you could do a mixed fabric too, right? So the abstraction is that we're abstracting it so the app.
Can you guys hear me now?
Yes.
Yeah.
Okay, just a second.
We are hearing you multiple times, by the way.
Yeah, I'm not able to disable my microphone.
I think you might want to mute your computer.
Yeah, that's the thing. The web interface doesn't work for good meeting.
Oh, the voice is terrible.
That's very frustrating. What about now? Better?
Better.
Yeah, great.
Great.
Okay, so do a quick recap. So what I was trying to say is that the slide here I'm showing is the base abstractions we're going to use to make the pipeliner more modular. So we should be able to add support for the different use cases and FFTs independently. So meaning that, some people can work on implementing the translation logic for the layer 2 unicast and layer 2 broadcast, while other people can work on the other use cases. Then, if you look at the document, the agenda, there is a link to an email that we sent to the mailing list with some carrot patches that shows that the prototype or the draft pipeliner and Fabric.P4 implementation we're working on. For the pipeliner, you will see there is an architecture already in place in which the pipeliner implementation is divided in 3 different pipliners, like filtering, forwarding, and next objectives. So the idea now is to rework that implementation, and mostly you will work on this, and I'll help him to better define this architecture, in which you can think each one of this pipeliner, so the filtering and forwarding, the next one, producing as a function that takes as input the flow objective and produces what we call pipeliner translation result, which is basically a wrapper around a collection of flow rules and groups and errors if the translation produces an error, and other metadata that are needed to apply that configuration to the pipeline. For example, if table entries need to be applied in a given order, or the same for groups, then we will use a list instead of a collection. Anyway, the idea is that you have this nice class called the pipeliner translation result that represents the result again of the translation and what should be applied to the pipeline. So once we define this architecture in which we have different translation logics for the given use cases, FFTs, each one producing a pipeline translation result, the way it will work is that the first thing we will do is to define the
test cases, unit tests for the different FFTs. The idea is that given a flow objective, so we will have a unit test for a different kind of flow objective representing the different kind of use case. The first thing we do, we define the expected pipeline translation result. And for us, this is easy because we've been working, with the OFDPA pipeline, and he has been writing Fabric.P4. So, at least we know what to expect, the entries to install on the table to support different use cases. Once we define the unit test, so the test cases, we also provide some sample implementation for some of these translation functions. The idea is that members of the working group, so in this case, people signed up to the Fabric.P4 working group, such as me, Yi, Do, Izzy, and Alper, should be able to work independently. Each one, for example, working on providing the implementation for a specific translation function, and they already have a test case to test their implementation against. So this should be enable them to work in a much more focused way without the need of understanding how the big trellis picture, how trellis works in general. So this is pretty much the plan we have to enable brigade members to contribute to this work. Is there any question? Yeah, I don't know if you want to add something.
I think I don't need to add something. Yeah, so currently I'm focused on working on refactoring the pipeliner to put the FFT to there and the personal use case, and I will upload the new patch today, so everyone can review the new patch of pipeliner. But I think everyone can review the Fabric.P4 and the interpreter first, so so can understand what is the basic in the Fabric.P4.
Okay, yeah, that sounds good. Yeah. Just to clarify, I mean, the reason why we're doing this is not just to enable many people to work on the pipeline implementation. I think this is something we need in general, like in ONOS. Like if you look at other pipeliner implementations, like the OFDPA one, it's basically like a piece of code with a lot of nested if else condition, each one trying to identify which forwarding function type we're trying to translate. So in this case, we're trying to give a clear architecture to handle the different cases. So yeah, it's not just to help many people contribute to this, but also to improve in general the architecture of the pipeline implementations inside ONOS. Okay, so if there's no any more other question, as you said, we will provide soon a patch to this new pipeliner implementation with the test cases, and then we can sync up with different brigade members. Each one can choose to which forwarding function type to work, and then they can start providing their implementation. And as always, we're happy to answer any question you guys have. If you want to write to the mailing list, it will be best.
Carmelo, what is the expectation to complete this architecture to start contribution?
As you said, maybe like we have a patch today or tomorrow.
All right.
Yeah.
So
what I mean with architecture in this case is, it's like, the interfaces defining the translation functions, the different FFTs, and then finally what we need are the test cases. So each one can work against a test case.
Okay, will we continue based on from the patches, or you're planning to merge your work onto the main line, then create a new branch or patch?
Good point. So we're planning on first merging this architecture without support for the different forwarding use cases, and then we provide the test cases independently. Maybe we still need to figure that out, but then the idea is that we provide the test cases, and then people can submit their code for the translation function for the specific use case. But yes, we plan on first thing and merging this architecture first.
Okay. And any plan of opening Jira tasks?
Yeah, absolutely. There will be Jira tasks for each one of these functions. Yeah. But then again, I mean, with the Jira task, we found hard in the past to synchronize, sprints we do internally at ONS. I mean, they're not internal, but I'm talking about the ONOS project sprint with the brigade work. We can try to do that. So have our brigade call more synchronized with the sprint planning and review, such that for each sprint we know, for example, in the case of the fabric, who's working on which use cases or not. But that's not mandatory. We have some flexibility there. But there will be Jira task.
All right, thank you.
Okay, so I think we can move on. The next item in the agenda is INT, and I'll leave the mic to Serkan.
Okay, thanks. Can you make me the presenter?
Yes, I will do that.
Andrea.
Give me a second, please. You should be presenter now.
Just a second. Can you see my screen now?
Yeah.
Okay, good. So, as you know, we have a design meeting in the Corp Build on Tuesday. So, in that meeting, we had a lot of discussion about the design, and here is the some notes from that meeting. It's posted by Carmel actually. So we agreed that we had a better technical understanding of how INT works. We realized that we are not fully understand the INT work, how it works. So also there was a guy from eCode, I couldn't remember his name, by the way. Sean, yeah, Sean. Sean talked about the northbound APIs that they are using in the northbound for the configuration of the devices. So we need to look there to understand if there's something usable API for us too. So, and the next item was there was an work group in P4 called Application Work Group, and they had a kickoff meeting last night actually, and it was very good indeed. I learned a lot of things from that meeting. Also, I will present some of the things that I learned from that meeting. So we also talked about the time plan for the INT. Before the Christmas, we decided to have a design proposal to present to the ONOS TST members, and if we manage, we can prepare a demo for the spring 2018, but we'll decide which event for the demo. And the whiteboard sketch is not seen very well, but there was a lot of discussions here. I just saved the pictures here for us to not lose. And so we think that we can use ONOS as a collector for the short term, but I think we can discuss this a little bit more detail. And so ONOS has a Kafka database we can collect using the ONOS and push the Kafka database, the collected telemetry data, and the other users can pull from that database. That may be our initial implementation for collector, but we will decide while talking about the architecture. Sorry.
Serkan.
Yeah.
Serkan, sorry, before I had some problems, so maybe I missed some part of what you said, but you know, is there any plan from the apps working group to provide like a collector implementation, open source INT specific collector implementation?
Getting from the application working group,
yeah,
collector.
Application.
I didn't see they implemented a collector already, but I think they have some plans, but there is nothing right now.
Okay.
I'm not sure, by the way.
Okay. So to clarify what you said before, I mean, my understanding during the meeting is that to use ONOS as a collection point or just a pass-through to a Kafka bus only for the initial phase of the implementation, just to have a place where to send all those INT packets, right? In the long term, we're not planning on using ONOS as a collector. We don't want ONOS to be the bottleneck.
Yes, I think so, because there will be a lot of CPU restrictions if we decide to use ONOS as a collector. But I will bring some ideas definitely when I have something for the design phase.
Okay.
Serkan, this is Tom talking. Just
Hi, Tom.
Just FYI, Intel has done some studies on the Kafka bus for some real-time, you know, and basically aspects of loop zero in sub-hundreds of milliseconds. They said that Kafka bus may not be the right thing to do, and on top of that, they were talking about how garbage collector can also cause problems in terms of adding, you know, intermediate delay and you know, garbage collector starts running. So I don't know, maybe we should revisit different approaches in long term. Maybe short term, maybe it's okay, but long term, if you want to get to sub 100 milliseconds,
I
need to think about it.
Yes, Tom. The same ideas could be used in INT in ONOS. So as we talk, we can use DCAE or VS collector for the INT telemetry collector. But I'm not sure how can we push this collector in the ONOS code base. So that's one thing that I am trying to figure out.
Serkan, that's I don't think we should have a collector immediately in the ONOS code base. It can live in the ONOS GitHub repository, for example, and I would say that this goes very well along with our ideas of a disaggregated code base that speaks, that is not tied together in one big project, but more as pieces that work together. So I think we can maybe take this offline, but it's not mandatory that the INT collector lives in the ONOS repository. Actually, I would argue that it would be better if it won't.
Okay, good news then.
The control aspects of it could live in ONOS then?
Yes.
Meaning to what creating probes or?
Yes. So from I don't know, the picture that Serkan showed didn't really do it justice, but the idea is that through ONOS,
you actually program the INT. So you program the pipeline, and then on top of that, you program the INT through some APIs. What those APIs are is still yet to be defined, but you basically tell ONOS, please enable INT on this set of devices, okay? Then the collector can live outside.
Someone else.
For, as Serkan was saying, for first part of this demo, it could be that ONOS acts as a pass-through for the collection of the data. So the data is taken by ONOS to P4 runtime and sent somewhere else. But for a second time, for a second phase, knowing better what the collector is and what are the requirements of the collector for better speed and not to create a bottleneck in ONOS, we could actually send the data already somewhere else from the device.
So when ONOS programs the INT, you basically could potentially put some tags in the pipeline, and those, because of those tags, it gets forwarded to some entity that could be the collector.
Well, the idea is that in INT you have an originator of the INT packet, some devices that are in the middle that just transmit the packet, adding their own information. Then you have a sink. The sink is the one that is responsible to send the data somewhere else, and where that somewhere else is, it's up to ONOS to program. I believe. Was that right, everybody?
Yes,
Yeah.
yes.
Yeah.
One thing we are sure about is we had a configuration API implemented in the ONOS site, and on this site we have an external collector, and we could send directly to the collector or through the ONOS. But which one will be the shortest path, I am not sure right now. Because I will come also, the P4 application working group has defined a reporting data structure and encapsulation format. So they are using UDP encapsulation, and they planning to send the reports directly to an external controller, not using a packet in structure or something else.
Mm-hmm.
Like sending SFlow or NetFlow data.
Mm-hmm. Mm-hmm.
May I ask, is that OpenConfig there?
OpenConfig would not be a way to send reporting data, sending telemetry data. OpenConfig would be the configuration site for the telemetry.
So the collector also use OpenConfig to communicate with the data plane?
Yeah.
Okay.
I think that I myself have some doubt on exactly what is the role of OpenConfig and what is the role of P4 runtime in the case of INT, because if you read the INT spec, it says that a device could push any data into the INT header, and if you go and then look at the OpenConfig, all the port data, port statistics, and a lot of other data about the device, also runtime status, it's defined by OpenConfig. So I myself have some doubts on what is the boundary, and maybe it's up to us to define that boundary.
I'm not sure fully understand you, Andrea.
So the problem is that both INT, and in this case over P4 runtime, and OpenConfig over GNMI both define ways of collecting some data from the device. In INT, it also defines the sync device and that type of specification. In GNMI, it's a single device information, but they both can query things like port statistics, for example. So who would do what? It's still unclear to me. That is what I'm saying. Was this more clear?
Yes, but in my opinion, P4 runtime doesn't define anything about collecting data, just defines some counters like in OpenFlow, but they are not, it is not defining a way of collecting telemetry data.
So the problem is, as far as understood, and please people correct me if I'm wrong, is that the data from INT act as basically a packet in. And that packet in right now is handled through P4 runtime.
No.
No, I don't think so, yeah.
No. I mean, it could be a packet in if you want to do it in a way that generates a lot of overhead. I think doing it as a packet in is a bit an overkill, but you could do it. You could send a packet as a packet in, but I think the best approach is that of sending that as an actual data plane packet somewhere to collector.
Okay.
Okay, give me another week and I will come with detailed slides to discuss on them, right? Okay.
Okay.
Thanks, Serkan.
Thank you. Oops. So our proposed timeline, as I said, we'll come up with a design to the TSD, ONOS TSD by the mid-December, and I hope we'll have an initial implementation by late February, and like in P4 running on Fabric, real hardware, and a collector implementation and a simple noteboard configuration could be our initial output, and we'll decide which event we can make our demo.
Yeah, so I think there's a type of TSD, ONOS TSD.
ONOS TSD, right? Okay.
Yeah. This is important, right? Because I mean, ACORD is part of the CORD umbrella projects, but we want to present these to the ONOS TSD because we're working on ONOS, and the fact that ACORD we use ONOS, it's another thing.
Where is the zoom out? No zoom out. Okay. So last night the application working group made the kickoff meeting. So they created a new in-band network telemetry specification and also introduced us a telemetry reporting specification. Those are drafts, by the way. So in the latest INT spec, the changes are they introduced INT over TCP in UDP, and they removed BOE speed in each 4B metadata, which I don't know the meaning. And also they defined the INT headers format and also provided the reference code for INT transit in P4 16. You can check the specs from this link. And also I learned that there is an ongoing work for the network device configuration, which is named SAI detail. And let me show you, it is, I think, very preliminary work. So what are they trying to do is to define the configuration of reporting metrics as far as I see. I will check these more details also, just let you know.
This is very interesting.
Yeah.
Let's understand well
This
If I
comes
understand
from
well,
the OCP project, by the way. Open
yes,
Compute project.
I'm a bit familiar with switch abstraction interface.
Uh,
So if I understand well, they're trying to come up with a interface that is, an interface to program the INT process that is pipeline agnostic, right? So this interface should be independent from the P4 program implementing INT. I think
so.
this is really relevant for us because we can definitely take inspiration from this interface and reuse that in ONOS, but with the difference that the ONOS API for INT should be network level.
Yeah.
But we can definitely take inspiration from this.
And I think these guys from Barefoot Networks.
Mm-hmm. Okay, that's very cool, actually.
Okay, need to look at it more detailed in the next days.
Can you put a link to this? Yes?
We've been requested to vacate this room by 9:55, so if we can, let's start wrapping things up.
I'm not sure I got the question. Can you speak closer to the microphone?
The question
she
was...
said that they have to close by 9:55.
Thanks, Erkan.
Oh, it's fine.
Oh, thanks, man.
Sorry, guys, you're speaking at the same time. Can you repeat the question?
We're running out of time. They said just wrap up. They want to be done in 4 minutes.
Okay. Yeah. Okay, so I don't know, Serkan, if you have any other slides.
Yeah. As I said, they defined the telemetry reporting draft and they defined some different headers for the reporting, such as tracked flows, drop packets, and congested queues. They are all different headers. And for example, if you experience drop packets, you need to use that header. And if you have in congestion state, you can start reporting using these congestion header. And also, as I said, they defined the report using a UDP-based encapsulation.
Okay.
So
there's no plan to provide support for other metrics?
For example?
Like latency?
Oh, if you configure your device using the tracked flows, then you can send latency for that defined specified flows.
Oh, I see.
Okay. So our next items are understanding the eCodes configuration of API and SAI detail, and deep diving P4 apps reporting spec, and running INT application, which Jong1 is currently working on, and also starting the INT design proposal. And if I missed anything else, that's my end of slides.
Okay, perfect. And just FYI, Nate and Kevin from NCTU are at ONF this week, so they're in the office. So I know they're working with you. He's helping them understand the P4 architecture in ONOS.
Yeah.
Nate?
Yeah.
Nate or?
Nate and Kevin from NCTU.
Nate and Kevin. Oh, great.
Okay.
For a week?
To wrap up, for more than 1 week, I guess.
Okay.
I don't remember. Okay, so the last point is about unit test. I'm not sharing my screen, but if you look at the agenda of the meeting today, there's a last point, unit test. I see that that Mehmed, Mustafa, and Ekber from Netsia are in the call. You guys signed up for the unit test working group area. I invite you to have a look at the agenda. There's a link to directory in the ONOS tree. But you can find the implementation of what we call the P4 info parser and the pipeline model implementation for P4. We need unit tests for those classes. We need help with writing unit tests for those classes. The usual unit tests like testing equality, and most important, testing the unit test for the P4 info parser. So if you would like to help with that, please get in touch with me or to the mailing list, and I can give you more details. And that's all for this call. Thank you all, and talk to you next week.
Okay, bye. Thank you.
Thank you.
Thank you.
Thank you.
Bye-bye.
Bye-bye.
Bye bye.